All right, so this is a video on solving exponential equations using the properties of exponents. So as you can see, we have this equation here. It's 5 to the x equals 25. And I know it's an exponential equation because the variable is in the exponent. That's what an exponential equation is. So the idea is that we're looking to get the same base for both sides. All right, and I think about this and I say, oh, I know 25 is 5 squared. So I'm going to rewrite this as 5 to the x equals 5 squared. And the moment I have the same base, then exponents are equal. So I can just say, oh, I don't really need the 5s anymore because it's kind of logical. 5 to what power is 5 to the second? Oh, x must be 2. So it's the hard part, is trying to get them into the same base. Not necessarily for this problem, but some other problems. So here we have 3 times 6 to the x minus 1 equals 108. Now, initially you might be thinking, I'm going to multiply these, but no, you cannot, because you have to do exponents before you do your multiplication, and you don't have values in here yet, so you can't. So when we're solving, we're trying to get x by itself here. The first thing we're going to do is, since there's multiplication by 3, we will divide by 3. And we get 6 to the x minus 1 equals 108 divided by 3, which is conveniently 36. You might see why it's convenient, and you might not. Again, thinking back to the last problem, we want the same base. Here's a base of 6. Here's a base of 36. Hopefully you recognize that 36 is the same as 6 squared. And once you have the same base, focus on just the exponents and rewrite that as its own equation. We have x minus 1 equals 2. If I add 1, I will solve for x. X equals 3 is the answer. And then lastly, we have a problem like this. It's a little bit different. We're going to incorporate a couple different properties this time. So we have 2 to the x. I'm going to keep that the same because I see a 4 there. 4 is 2 squared. Okay, so we have 2 squared raised to the x plus 3 power. We need to use our properties of exponents. And since this is a power to a power, the property for power to a power is we multiply the exponents. And since multiplication is commutative, we can actually invert this. We can swap places here and then multiply each of the pieces by 2. It doesn't really matter how you do it. So I'm going to distribute that 2. There's a lot of 2's there. This 2, the exponent, into the exponent x plus 3. So that's going to give me 2x plus 6. When I get the same base, I can take my exponents down into their own equation and then solve for x. I get negative x equals 6, so x equals negative 6. So that is solving exponential equations. Now, they obviously can get much more complicated. These are all going to be reasonable integer value answers. You might get some fractions occasionally, but there are no irrational answers for this particular